Hey everyone, let me just move this up here. All right, I'm going to go through this slide with you guys. So this is the graph that showed the basketball player shooting the hoop, and the red line represents the movement of the ball in the air. So it says do your best to label the following. All right, so the first thing I want us to always do is remember that this is the y-axis, the one that goes up and down, and that our x-axis is down here. That's going to help us with the y and x intercepts. All right, so first thing is the y-intercept. Well, when I go to the y-axis right here, I'm going to trace the y-axis, see where my graph crosses the y-axis, and that's actually right here. This is going to be labeled as a point. So this point is called 0, 6, and this is the y-intercept. So this is where the story starts. We can, deduce that the person who shot the basketball was 6 feet tall. Okay. All right. The second one is the x-intercept. So we're going to do the same thing that we kind of did with the y-intercept. We're going to trace our graph and see where it hits the x-axis, which is right here. All right, so this point is 14, 0, and that is the x-intercept. Now, what's important is most times there's actually going to be two when we're looking at a graph of a parabola. There's only one here, but we can kind of think like if we extended this line and extended this curve, there would have been another one on the negative side of the graph, okay? So usually there are two, and again, we label the x-intercept as a point. All right, the next thing, there's actually three. So we're gonna look for the vertex first. The vertex is either the highest or the lowest point on the graph. In this case, we have a highest point right here. And this point is actually gonna be labeled as 6, 12, and that is our vertex. Because it's the highest point, it's also labeled the maximum. Okay, so that's going to be in purple as well. We don't have a minimum on this graph. Okay, if our curve was kind of upside down like this, we would have a vertex right here, and we would label that vertex as the minimum. Okay, in our story, this also happens to be the highest point of the ball when the ball is shot. Last but not least, we have the axis of symmetry, which is right here. All right, this cuts the curve in half. So on one side here, represents where the ball's height was increasing. On the other side of the axis of symmetry, that represents where the height of the ball was decreasing. All right, the axis of symmetry is right in the middle. And if you notice, this is really important, the vertex is always on the axis of symmetry. What's different about the axis of symmetry is we actually label it as an equation. So it's going to be x equals, and I'm going to look right here, where does this axis of symmetry cross the x-axis? Well, it crosses it right here, which would be 6. So I represent the axis of symmetry by saying x equals 6, which is different than the other parts of the graph that we label as points. We did that for the y-intercept, the vertex, and the x-intercepts. Okay, last but not least, this whole thing, we've been calling it a curve this whole time. The whole thing is actually called, I'll write it right here, a parabola. Okay, so that's what we call the curve that a quadratic function makes. It can be either this way, like we have on our graph right now, or this way, like I showed you before. Okay, so those are the parts of a quadratic function.